Hello, everyone, and welcome to this stream. So, pretty excited about this particular session, metrics and traces with Timescale DB. My name is Sam Pathak. I'm working as Director of Technical Evangelism at CIVO. I'm a CNCF ambassador, and you can find me on Twitter at the rate Sam Pathak, where I'm very active, and you can find all the work and initiatives that I'm doing. Uh, Last week was pretty awesome. We did a CI/CD week. We discussed amazing projects: Tecton, Jenkins, Argo CD, Captain, and one more was there. So we have the complete playlist I have uploaded, and the complete playlist is available, so make sure you check that out. And today we'll be discussing about timescale DB primarily, and also I was just chatting with Vineet, and there are some important concepts that he will go before diving to timescale DB, which I think is a super cool idea. So he'll be diving into some of the concepts, like if you have not kind of heard, or if you don't know what traces are exactly, how the metrics looks like exactly, some of the terms, Promscale, Timescale, time series database, and what Timescale DB is. So Vineet has prepared a very awesome flow so that you people can understand, in a way that that would be from this level, and it goes to the next level. And there are some fancy dashboards in the end as well. I don't want to spoil all the fun, but yeah, I couldn't wait. Some things are there. So thank you all for tuning in. Very happy to see you here, and please comment hi and where you're tuning in from, because that's what it's good. The interactive sessions are always good. And also keep sharing on Twitter like what you are learning. You can tag Vineet, myself, and Timescale DB, and let us know like how and what you have learned from this particular session, because that is pretty important. And what else? Yeah, first things first, you have to subscribe to the channel. Make sure you subscribe to the channel so that you don't miss out any of the sessions or streams that I do, or any of the videos that I upload and will upload. Also, please be sure to be nice in the chat to each other and to the speakers, and maintain the decorum of the stream. That is pretty important. With that, I think we can start. So today I have Vineet with me. He has been there in the open source community for quite some time now, and contributing to various projects, working now. So he knows like Kubernetes, he knows a bunch of other things, Prometheus, Grafana, and obviously in the time series domain, he knows a lot of stuff. So he has been active contributor to various projects. So very glad to have him on the show. So thank you so much, Vineet, for tuning in, joining in. Please introduce yourself, tell us more about your work, what you do, and all that stuff to the community.
Thanks, Sam. Thanks for having me, and thanks for a wonderful intro on my presentation as well as myself. So, hello everyone. Happy to be at Sam's YouTube channel, and I've been following it for a while now, and awesome content. And he's up to date whenever a new technology comes up, and he like you're just covered. Like if you follow his content with YouTube and all the newsletters he does. So coming to myself, my name is Vineet, and you'll be hearing more of my introduction in the slides. But I'm based out of Hyderabad, India, and I've been involved with CNCF community for almost like 3+ years. And I worked on various projects, starting from Kubernetes release team, being the Kubernetes contributor, to working on Open Policy Agent, working on Cortex, and Virtual Kubelet. So there are many projects I don't remember because as the time progressed, I've been pivoting to different projects of my interest and work. So finally, I landed at Timescale and working on observability stuff today. And uh, we have been doing some amazing things at Timescale on observability side of things. So you'll be seeing it today in presentation. So yeah, can't wait to present.
Awesome. So I think we can get started, and let the fun begin. And if you have any questions, just put them in the comment, or when you're watching it, when you're watching the recording, or if you're watching the recording, then you can post in the comments. Vineet is there on the Kubernetes Slack as well, so you can reach him out over there as well, or you can just tag me at the Twitter, and I can reach out to him. So anywhere, or you can have the the Timescale Slack, so you can reach him out over there as well. So plenty of ways to communicate and ask questions.
Yep. So let's get started. Like Sam, can you just confirm me that you're able to see the slides that I'm presenting?
Absolutely, I can see it.
Yep. So hello everyone, let's get started. So today we'll be discussing about metrics and traces with TimescaleDB. And when I say TimescaleDB and metrics and traces, you should just get that first point clear is that it's a single database for all your observability data. So you don't need to maintain a separate database for metrics and separate database for traces. It's all one database. So you just need to manage one DB. So that's the context behind this talk. And let's get started. So, what is a metric? First thing first. So, a metric is nothing but a metric name, labels, timestamp, and value. So, today we use metrics in the monitoring world. So, if you are in the cloud native ecosystem for a while, or you're working with microservices in the cloud, you already have instrumented your application with Prometheus instrumentation libraries to expose the metrics, and you might already be using Prometheus to store, visualize all this metric data. So this is a metric, just to be clear for the beginners on what is a metric and what is a trace. So we know what is a metric, and now let's get started with what is a trace. So today in the complex cloud native era, we have moved from monolithic to microservices. And when I say microservices, each and every service just does the as minimal job as possible and as independently as possible to remove the friction during developments, maintenance, and upgrades and all this. So here you can see that there are a bunch of microservices like front-end news, comment, advertising, and database. So these are the microservices in the current world. So what is a trace? Like you need to know what is a microservice environment to understand how does a trace get built. And trace is nothing but a request lifecycle across all your microservices. So when I say trace, it contains multiple spans. Span is nothing but a building blocks for a trace. So span, you can simply think that span is an action performed during a request lifecycle. So here you can see that the front end is calling the news service, and it also calling the advertising service. Like once you log in onto the front end service, it tries to get the news onto the home page and advertising pop-ups towards the left and right corners. And also once the news service serves all this content, then there will be a comment service which powers up all the comments which have been done on a particular news article from querying them from the database. So you can see all the request life cycles. So you don't need to understand the complete architecture to understand the request lifecycle. If you just look into a trace, you should be able to understand what's happening in the complete hundreds and thousands of microservices. So it's as simple as that. And about me, so I just wanted to give you the context and then jump into who am I and why am I here. So as you all know, my name is Vineet, and I work as an engineer at Timescale in observability team, and I work especially on the projects Promscale and TOBS today, which we'll be discussing today. And I'm also the maintainer for Open Telemetry operator. So if you are planning to use Open Telemetry for in your Kubernetes clusters, you should definitely check out the Open Telemetry operator. There are so much of advancements happening in the Open Telemetry space, and even operator is getting actively new features merged. So it should be quite exciting for you if you're looking for an Open Telemetry deployment in Kubernetes. And I enjoy reading books and cycling. So if you are in Hyderabad, you should definitely reach out to me in Twitter or in CNCF Slack or in Timescale Slack. So I should be available. So we should definitely catch up if you are in Hyderabad, or if you have any questions around all those technologies and topics. So let's continue with our presentation. So we have seen what is a metric, we have seen what is a trace, but what does a trace data contain? So as you know, when you see a trace, it's a request lifecycle, but a request lifecycle will have so many attributes. There is so much of metadata involved in this trace, and how do you get all this data into one single structure? So when I say trace data, it's obviously a complete trace struct, and then you have the subfields as spans, links, status code, operations. When I say operations, these are nothing but the API calls and events. When I say events, these are logs, and start time, end time, and duration, status code, resource attribute. So there are so many things in the trace data. So if you manage to instrument your applications using tracing libraries, then you should get all this data out of the box from your services, traces, and it should be much easier for you to understand what's exactly happening inside your application, uh, based on per request basis and per client ID basis. So you can capture all the metadata to debug uh, a downtime or latency issues. So, and let's see about why is it important traces, and while very valuable, low adoption, why. So it's relatively a new data type. So as the main reason why I'm concentrating on traces today is that it's still getting started, and like it's in the still in the adoption phase. So why is it? Because it's relatively the new data type. So everywhere, like all the applications today already have logs and metrics, but traces is like the third step towards your instrumentation. But if you're just getting started, should start with traces, because trace already includes metrics and logs within it, at least in the future version of open telemetry. So yeah, and it's high initial investment, as you need to manually instrument it, because if you want to capture so all that attributes, you need to spend some time to capture all this data and to understand what are the convention standards to capture this data, and it's hard to get value once you instrument it. It's not just visualizing the trace, but you should know what are the day to operations you can perform once the instrumentation is done. So there is no the ideal way of capturing the value from the traces. So that's the reason it's very valuable but low adoption at the moment. But sooner you'll be hearing more about the value and what traces will add to your existing stacks. And here comes the open telemetry and Promscale to the rescue. So we have seen what is a trace and what value can it add to your existing microservices architecture. And we will talk about Promscale as the single store database for all your tracing data and metrics data. So let's get started. So open telemetry. Open telemetry is the new standard of instrumentation, and it's a CNCF project, and it's recently incubated in the CNCF ladder. So from sandbox to incubation, and it's vendor agnostic. So previously with tracing, people have different contexts that if once you instrument, you cannot change it. But here it's completely vendor agnostic, and you just use the open telemetry. You just use the open telemetry client libraries, and you should be covered to send all the traces to any vendor backend you would like to send it to. So it should be totally fine. And this new open telemetry standard covers all the metrics, logs, and traces. So which means a single instrumentation library to capture all the observability signals. And it also has its own protocol and semantic conventions, which makes the instrumentation much easier, because you don't need to follow different standards and get confused on how to get this done. But here you can get everything out of the box. And there is also instrumentation libraries for almost every language, like Erlang, Go, Python, and everything. So it dramatically reduces the instrumentation efforts, because the more and more instrumentation libraries, the more the adoption and more the examples for you to getting started. And the core and the important component of the open telemetry uh, project is the open telemetry collector. I would say the open telemetry collector is the heart of open telemetry. So what is an open telemetry collector? So as we have previously discussed, that to get the traces out of your application, you need to instrument your application. So now your application has instrumented with traces. So now it emits the traces, but where do you need to send these traces, and who captures it, and how do you forward it to the desired backend or an OSS backend? So there are multiple ways, and different backends support different uh, protocol. So you need to change this traces to the protocol supported by the vendor, and you want to do some sampling, and you want to do some processors. And even like, let's say if you have hundreds of microservices, and like few services are like 3 or 4 years old, which are instrumented with Agar client libraries. So you do not have the bandwidth to change the existing instrumentation for Agar to open telemetry. So how do you make sure that all this applications instrumented with different tracing libraries get forwarded and accepted by the open telemetry collector, and gets processed and sent to the desired backend? So all this is covered by the open telemetry collector. All these problems are completely served by the Open Telemetry collector. To just give you a brief idea from this diagram, so here in the middle you see the Open Telemetry collector. On towards the left you can see that your different microservices which are emitting the traces using Open Telemetry SDK, eager client library, and it can be Zipkin, anything. So it's totally possible. And you will configure in the Open Telemetry collector that what are the different receivers uh, you want to configure to accept the traces. So if you are using a Zipkin client library, then you need to configure the Zipkin receiver in your Open Telemetry collector to receive the traces. So once these traces come into the Open Telemetry collector, they just get accepted into the receivers you have configured based on the client library you have used. And all these traces from the receivers will be forwarded to the processor within the Open Telemetry collector. So the processes are nothing but you want to do some filtering or you want to do some batching, all this. So you can write your own processors and contribute to the upstream. So there is an other repo called Open Telemetry collector contrib, which contains the external contributions which are open source processors, receivers, and exporters in that repository. So you should definitely check out. So it has wide range of support for receivers, processors, exporters, and extensions. So that's the essence of the collector. And in the collector you also have exporters. So where do you want to export? So let's say if you want to export to Promscale, Promscale is the right path, the ingest path of Promscale accepts the OTLP, the Open Telemetry Line Protocol. So the OTLP, the abbreviation for the keywords you see here is that Open Telemetry Line Protocol. So it is the protocol that Open Telemetry supports, and it's the standard from the Open Telemetry which multiple vendors and OSS projects today adopt to. And Promscale is no different in that. So OTLP is supported in Promscale. So all you have to do is configure the OTLP exporter. So once the trace is received in one of the receivers you have configured, and it gets processed and it gets exported from the OTLP exporter to the Promscale. So if you have Kafka as the backend, you just put the Kafka as the exporter, and if you have XYZ as an exporter, you just configure it and point the desired endpoint to the backend you want to push these traces to. So this is the Open Telemetry collector in the overall.
Yeah, I think that is pretty important aspect. Like the open telemetry is right now evolving, at a very rapid pace, and this is the kind of, as Vinith said, the heart of open telemetry. So you have your application, then you use your open telemetry SDK to for emitting your metrics, traces, and the logs, and then you can have the receivers that will that will receive those data, and then you can have the backends defined where you actually want to send that particular data. So that's how it is. The SDKs obviously makes it kind of easy, so that within your applications, obviously you might have written an application. Not every day you are writing a new applications. There are legacy applications that you have microserviced, and you are running them on production on large scale, and you want to implement open telemetry. So you can do that. You can have the SDKs implemented, and you can have emit traces from them. You can also, I mean, there is some amount of trace data that also gets captured when you implement kind of service meshes. So if you have heard of service meshes, there is tracing, which is a big part of the features of service mesh that you'll often see. Like, say that you have 100 microservices and one microservice is failing, or one microservices is giving some latency. Now how do you find that? That comes from a trace. So the trace will obviously track, and with a fancy UI or with some mechanism, it will let you know that, okay, this is the microservice, exact microservice where your latency is much higher, and then you can fix that. So that's where, I mean, this is just one of the very simple use cases of traces, but traces have a lot more use cases, because in today's world microservice architecture is huge. You'll not be only having one microservice or two, because it's not a simple application that you are deploying on a beast Kubernetes cluster or anywhere. So you will be having the n number of microservices. Even there is a concept of nano services, if you have heard. But you'll be having those services, and the connectivity between them, the latencies between them, how they're working in together. If there is a failure at login, then which step at login it is failing. So those set of trace, those can be analyzed and reported and fixed very easily if you have traces implemented within your application, or if you have some mechanism like service mesh, which gives you some ability to have the traces implemented and analyzed. I just told that because there was one question like, can you explain the traces one more time?
Okay, no problem. So, uh, if you have like if you need any detailed explanation on the traces, like do put it in the chat. Like at the end, we can just reiterate me and Siam together, and we can also share the introductory blog posts on how to get started with tracing the open telemetry. And also, like the more we see in the questions in the chat, we could help you on that. And also we might create a like add to the Twitter thread in the comments for all the questions you have asked. We will just add all the resource URLs there, so feel free to add the questions. We will get back with all the answers either in the YouTube chat or in the Twitter. So yeah,
Yep.
so let's move forward. Yeah, so like we have seen the instrumentation part, we have seen the collection part of all the traces, but there is an other important thing in this auto instrumentation with open telemetry. So you don't need to instrument at all. There is also a support called auto instrumentation with Java and Python and Node. So all you have to do is you just need to run this Java command in your Java application, and this open telemetry jar gets injected to your existing Java modules, and it should just give you the auto instrumentation. But just keep in mind, the auto instrumentation doesn't give you the deep insights you expect from the manual instrumentation. It just gives you that overall code flow in the high level. Okay, this is where it entered and this is where it exited. So it's in the a bit high level, but you don't need to put any manual instrumentation efforts. So that's also a win for easy getting started. So this is the auto instrumentation example for Node.js. Here you just injecting the JS library for your existing applications. So it should be as easy as you see it here. And more information on OpenTelemetry is completely in the OpenTelemetry.io, and there's huge efforts happening in OpenTelemetry. So you can just follow up with OpenTelemetry either by OpenTelemetry Twitch or the YouTube and the CNCF. So like there's so many advancements, so whatever I say today might be updated by like in couple of months. So the project is going through huge iterations and new features and everything. And just an heads up and a fun fact, today open telemetry is the second largest contributed project after Kubernetes. So it's the second largest project with all the contributors and everything. So keep an eye. And what is timescale DB? So here comes the fun part, and here comes why am I here? So now we have seen what is a metric, what is a trace, and how does it make your life easier. But let's check what is timescale DB and how does it help with your metrics and traces. So timescale DB is designed for time series data. So when I say time series data, all the metrics and traces are also time series in nature because they also have a timestamp and some metadata which gives you value addition during debugging or to understand the observability of your systems. And timescale DB also offers rich time series analytics. So we do have some analytics functions and analytical features within timescale DB, which gives you that out of the box. And timescale DB supports massive scale and performance. So when it's time series data, we know that, like for example, every second you might be inserting some data. So in a week, in a month, and a year, how many rows your table can scale up to millions to billions of rows. So that, which means we already support massive scale, and we are in production in many top companies and all. So yeah, you're covered with us if you just use timescale DB, and the performance is also brilliant, I should say. We do have some benchmarking blog posts and here and there, so you should see the performance of timescale DB. And the timescale DB completely works with your convenience and familiarity of SQL. So we are 100% compliant with SQL. So it doesn't mean that again you should learn a new database and again you need to learn a new querying language and all that. So it's completely compatible with SQL. And SQL database of timescale DB, like when I say timescale DB, it's an SQL database and it is optimized for fast ingest because as the time series data itself is like high velocity in nature, so the insights keep happening, whereas a traditional database might absorb, like ingest only on specific action is performed, but whereas time series data, without even any action being performed, the state is always observed and ingested into the database. So it's optimized for fast ingest and complex queries. uh, TimescaleDB also does something called automatic partitioning, which we will discuss in the next slide. And we also have advanced time series analytics. So we have a new project called Timescale Analytics, which gives you some analytical SQL functions to perform 99 percentiles, approximates, and all that. And we also do continuous data aggregates. So it's like uh, compacting your time series data into like all merging different data points into one, and also it's something like recording rules. You can think like in Prometheus, if you are aware of recording rules, it is something like recording rules, but this offers much rich features than recording rules. It has much richer approximations. So yeah. And time series data. So when you know time series data and think of time series data, just in your mind, that what is a time series data? So time series data usually has high velocity and it is continuously grows over a period. But how do we handle it in tables? Am I serious? Because just think, like if you are ingesting time series data into a table, what would your table size be over a period of time, and how does this querying work, and how do you scale it while querying like a table with billion rows? So that's totally possible. So with timescale DB hyper tables, so you know the generic tables in the RDBMS, right? So the hyper tables are very similar to that in nature, but we have some special capabilities with hyper tables. Hyper tables, you can think as that there are multiple small tables under the hyper tables, which are partitioned based on the data into chunks. So based on the key space or the region, based on different factors. So hypertables are an abstraction layer and a primary point of interaction for you during querying the data or inserting the data and altering the tables. So you just need to use create table hypertable prefix, and the hypertables just gets created in the timescale DB. So just iterating back to what is a timescale DB, just to give an heads up. So timescale DB is completely built on the foundation of Postgres. So like if you have an existing Postgres database in-house, all you have to do is install the TimescaleDB extension, and your existing Postgres database should work as the time series data out of the box. So TimescaleDB is not a completely new database. It's built on the foundation of Postgres, and TimescaleDB can be installed in your existing Postgres setups by just installing the extension, and all these features should work out of the box for you. And we do have some analytical extensions to perform advanced analytical functions. So you should definitely check out timescale docs to understand how all these things work. So let's see what is a Promscale. So like we have seen what is the timescale DB, it's the database storage layer. Uh, you have seen it. So it's the storage layer, and here you can see that. Okay, Sayam, are you able to hear me? I'm just a bit curious. Like, is my audio?
Yes, yes, it's
Yeah,
perfect.
yeah. Sorry for that because I'm a bit curious. Yeah. So yeah, what is a Promscale? So a Promscale here, you can see it's a completely open source project. It just works as a bridge between your observability data collectors and the database itself. So it's a stateless single instance application. So whereas like let's say if you are like Promscale works primarily as the remote storage backend for your metrics data. So you can just think it as a drop-in replacement for your Thanos, Cortex, Victoria metrics, and any other OSS monitoring remote storage projects out there. So this is also complete open source. And whereas like many other OSS solutions today in the industry have like 5+ microservices should be deployed, managed, and taken care. You definitely need an SRE team to make sure all these applications are in well state and working as expected. But whereas with Promscale, all you have to do is timescale DB is like you should just run a database as similar to as running in any other database, and Promscale is just a single deployment. You can just deploy a single replica. It's completely stateless. You don't need to provision any persistent volumes or anything of that kind. So Promscale is just deployed and it is connected to timescale DB, and all the data coming from your Prometheus or Open Telemetry collector and everything just gets accepted by Promscale, and this is the Promscale just ingests this data into timescale DB. So like before, like this is the complete positioning. I just over jumped into the Promscale because I was excited to explain you what was Promscale. But coming to the Promscale, it's an observability backend powered by SQL. So it offers you some unparalleled insights. When I say unparalleled insights, because it offers you the SQL as a query language. It has all the competences and analytical functions out of the box in the native SQL, and TimescaleDB also offers some advanced analytical functions which are available for you. So which should help you to analyze, correlate metrics, traces, and business data. Also, just imagine like if you are storing your metrics traces in the TimescaleDB and you also are storing business data in the TimescaleDB, you just run an SQL command to correlate your metrics to traces to your business data. So it's as simple as that. You don't need to have multiple databases, multiple query languages to get all this data into one picture. It's just one query language to get correlate all this data. And the database is as the Promscale is storing all this data into TimescaleDB, it has the proven foundation of PostgreSQL, which today supports petabyte scale. So all the PostgreSQL native features like high availability, replication, compression, everything is available in TimescaleDB. So we should be fully covered with all those features. And it's easy to get started. All you have to do is just set up two components. One is the database itself. We do have Helm charts and everything, so, Docker container and everything. So Timescale DB should be up in just one or two commands. You are just away from that. And Promscale is also a single application, so you can either run it using the Docker container, bare metal, or using the Kubernetes Helm chart. So all you have to do is two applications up, and you should be done with all your storage backend for your observability data. So this is the complete architecture which I was speaking. So you here you have the Promscale. So Promscale, when we say Promscale, it's the connector which I've been talking, which is stateless, and the database itself. So once the data comes from the Prometheus Open Telemetry, it enters into the Promscale connector and it gets stored in the Timescale DB. So on the right here, you see the visualization tools, how you visualize all this data. So if you are using Agar, as today Promscale supports trace ingestion and metric injection, as we discussed in the uh, prior slides. So Agar UI is completely compatible with Promscale. All you have to do is use the Agar UI Docker image, which we published, which includes a gRPC plugin to query the Promscale. So it's the same Agar UI, which I'll be showing in the demo. And you can also configure Grafana to the Promscale. So Promscale also is 100% Promql compliant. So like if you want to query SQL, you'll be querying directly the Timescale DB with any tool that speaks SQL. So if you have some BI tools, the business intelligence tools to get some deep insights, which are queried using SQL, all these tools should be compatible with Timescale DB. And if you are using Grafana for charts, visualization, and everything, so you should be using Promql with Prometheus data source as the target as Promscale, and it should work fine. And if you're using Agar for the traces visualization, it should definitely work. So any tool that speaks Promql also can connect to Promscale and query the data which is stored into the Timescale DB. So this is as simple as that. So you don't need to run a bunch of microservices, scale them, manage them, and upgrade them and see their health. It's just the database itself. So if you are already using an S3 or GCS storage systems in the cloud, you can definitely use Timescale DB cloud offering today. So the database is completely on our end. All you have to run is Promscale in your local environment, and the data gets shipped to the database setting in the cloud. So we do have 30 days free trial for the cloud Timescale database hosted offering. So you can definitely check it out to easily get started and to get the instant value out of the setup. And we have seen what is Promscale and all these data types, but I just wanted to say, as trace data is a bit complex, how do we store it in the relational database? So as you can see on the top, Open Telemetry span data model contains the name of the span, start time, end time, and the parent span ID. What is the trace ID the span is associated with? What's the span ID of a particular trace? The trace flags, trace state. So all this together is known as span context. And you have events, which are logs, and you have links to aggregate all the spans with a common metadata, and you have attributes which you want to capture from your request lifecycle. So this big is the Open Telemetry span data model, and it is much more too. So it's just the essence, the critical and important attributes of the data model. And all this is designed to sit into multiple hyper tables and the normal tables of post relational database. So this is how the schema in Promscale is designed. But don't worry, you don't need to understand the schema at all. Like we have built views in the relational databases. Like you know already what is a view in the RDBMS. So we have built a view for you. So all you have to do is query from that view. So all this data is in one single table with different columns. So you should be able to query them directly using the trace ID and span ID. So you don't need to learn and understand the schema. So it's totally covered and it should be much easier for you. And demo time. So let's see what do I have for demo. But before we jump into the demo, I just wanted to give you a quick overview of what is the demo I'm doing and what is the architecture I'm talking about today in the demo. So we also have another open source project called TOBS. The TOBS abbreviation is that the observability stack for Kubernetes. So when I say the observability stack, it's an Helm chart and a CLI. So what you have to do is you just need to do TOBS install, and it just installs all this observability stack into your Kubernetes cluster. So what is an observability in the Kubernetes cluster? It should do the monitoring, it should do the tracing, and it should do the logging. But today we do not have the logging support yet in the Kubernetes cluster, but we are planning to add it in near future. But coming to the traces, we do automatically deploy the Kube Prometheus for you, the complete monitoring stack today. So which includes Kube State Metrics, Node Exporter, and Prometheus scrapes all this data from the Kube State Metrics to get the state of your API server, and Node Exporter to understand how is each and every node in the cluster performing. And it also uses Kubernetes Mixins, the out of the box dashboards to understand how is your Kubernetes cluster performing and to fire alerts on some default alerts which have been configured in the Kubernetes Mixins to the alert manager. And this Prometheus is completely managed. Prometheus and alert manager is managed by the Prometheus operator. And we have Grafana also deployed as a part of Kube Prometheus. And using TOBS, we also deploy PromLens, which helps you to build Promql queries with much more ease and to inspect a Promql query. And the Promscale itself, so which we have discussed. So like all this setup is pre-configured, so you don't need to do anything. It's just one command away. You have to do TOBS install, and it just gets installed in a Kubernetes cluster. All you have to do Helm install the Helm chart. So the Prometheus does the remote write to Promscale, and all this metric data from Promscale gets written into the TimescaleDB. And from Grafana, you can do the PromQL queries or the SQL queries. It's totally your choice. And here you see towards the right, it's we have recently added the support, but it's today a feature flag based deployment. So this is completely the tracing stack. So if you just do TOBS install -hyphen tracing, so it installs the cert manager, which is a dependent component for the OTel operator, the open telemetry operator. And once the open telemetry operator gets deployed, we also deploy the default open telemetry collector, which accepts the traces from Aegir OTLP. And the open telemetry collector ships the traces which are received from the applications running in the Kubernetes cluster to the Promscale, and Promscale writes them into TimescaleDB. And you have Aegir query, the visualization layer also deployed. So Aegir queries the Grafana, and Grafana reads the traces from the Promscale. So this is the complete architecture. This might look a bit complex, but you're just one command away. Trust me. So you should be everything set up. And I think already the 50 to 60% of all these components should be existing in your Kubernetes cluster already. The additional components are nothing but the Promscale and TimescaleDB as the single data source database for all your observability data. So let's get into the demo. So this is the Grafana instance from the setup I have showed you in the previous slide. And I have built some databases using SQL, completely with SQL. And let's see how is the metrics with SQL is like. So today we'll not discuss about Promql or anything. It's the data sources. So before we discuss about this, let's look into the data sources we have. So I have 3 data sources in this instance. So this is also pre-configured. If you just do TOBS install, all these data sources will be pre-configured for you. So the first one is the Prometheus data source itself, but the target is Promscale. So Promscale has all the Prometheus endpoints like the ingest query and everything supported within the Promscale. So you can just query Promscale using the Prometheus data source and using the Promql as a query language, and it should definitely work. And Promscale SQL is nothing but it is it is querying the database itself. Currently, I'm using the cloud instance of TimescaleDB. So the database here you're seeing is completely hosted on Timescale Cloud. So and here you have the Agar as the data source. So if you want to visualize traces from Grafana, you should point it to the Agar query, the UI component wherever you have deployed. So all these components are deployed in the Kubernetes cluster. So these are the data sources we have. And let's check out the dashboards which are powered using the time Postgres SQL, the Timescale DB as the data source. So metrics with SQL. So I have built three dashboards using SQL as the query language to get some deep analytical insights. This to get this insights from using Promscale, it should be too advanced to get to write this kind of queries. The first point, and the second point is they might be uh, like few queries also might be impossible to do in Promscale. So the first panel you see here is the title itself explains you what this panel basically represents. Containers memory provision versus 99th percentile of memory utilization. So on the Promscale timescale docs, we have tutorial for Promscale. We have a separate page to explain how to run SQL queries with Promscale. So one interesting example we have is at the end called Danlu's bonus other example. So a simple way to get more value out of your metrics is a blog post. You should definitely read it out if you are from the observability world to understand how Danlo explains how to get the day to deeper insights from your metrics. So this is the SQL query for it. So don't worry, like though it looks this big, it's all the subqueries and joins we are doing here. So it should be much easier for you to understand. So with this query, what we are trying to achieve is that we want to understand what how much memory is your container actually using in the 99% percentile of time versus actual provisioned memory with the container. So this having this kind of insights from your observability data with SQL, you can reduce your resource cost with so much like 5x or 10x, because here you can see that the maximum memory used is way lesser than what's been allocated in your containers. So by observing this kind of stats, you can under provision your containers and get the actual cloud cost to a bit lower. So this is one of the SQL queries. And here you can see that how long does your garbage collection take in the Go application. So this is the 99 percentile we have calculated. So at 99% of the times, how much time is your garbage collection taking? So it's almost like 3 milliseconds, 0.3 milliseconds. And you can also see the SQL query, what I have written to get this insight. So the query is just 3 lines. All you have to do is select value as pod ID and percentile count. So it's an analytical function to do percentile count of 0.99 and within group order by value of P99, which I'm saying the column name as P99, and from go GC duration second. So this is the metric which explains you that how much time is your garbage collection taking to perform it. And we are just doing where like is the pod name and everything is working as expected. So that's the and we're doing an order by. So yeah, just three lines of SQL query, and you can get this kind of deep insights from your metrics. And like also the like one interesting point is that like if you want to understand how much data points do you have in a particular series. So this table gives you an idea of how many data points you have in this Go GC duration seconds metric with different series. So series is nothing but a metric and the combination of labels it holds. So all the series have 43,800 metric data points, I should say. And if you see, there are some pods which just have like when I say pod, because you can see here the app name is Tops Promscale, which has 8,738 data points. So it just gives you a way to understand how much data points a particular series is consuming. And with Promscale, you can also do per metric retention. So you can just give a metric and say that you want to have Go GC duration second metric retention to 5 days, and you want to store your business application metrics for 180 days. So it's totally possible. You can do metric retention based on a metric to save on storage costs. So that's totally possible. And these are just a beginning getting started. So all this visualization and dashboards you see here is like just like I spent like less than 5 minutes to power this dashboard. So just imagine if if you can store all your observability data into the timescale DB and use SQL as the querying language, sky is the limit. You can correlate, you can add some business metrics columns to understand why is an X value is in such a surge or a spike considering a business value. So it should give you a deeper insights into your existing stack for observability and both with the business metrics. And let's jump into the traces side of this visualization. So we have something called service performance. So I in this demo environment, I've deployed some demo applications to get some traces. So that's how all this traces are getting ingested into TimescaleDB, and even all this panels you see here is completely SQL is used as the query language. And here you can see the first panel here. This table represents you that the highest error rate in last 24 hours, like which API from a which service is getting the highest error rate. So spans with error are 31. So like front end service get ads is giving you the highest error rates, and the total spans received so far are 130K. So like this, you can just analyze how is the errors in a specific operation and API in your trace data which has been captured. So whereas with Agar, like this is the Agar which queries the Promscale, like this is the traditional Agar UI. If you see the Agar UI, all you can get in the trace visualization is that the traces. So you do not know the deeper analytics, aggregated data of how a particular service or an operation is performing. It just gives you that, okay, this is a trace and this is the duration, like 4.8 milliseconds it consumes, and this is the process tags logs. All this data is captured in a general trace, but you do not know how to capture the right value from your traces which have been stored. So Agar is the only OSS way of visualizing traces today in the cloud native world. So if you are using open source, you should be using Agar. And even Grafana internally uses Agar clone for trace visualization. So here with having Timescale DB as the database layer, you can use Agar for querying traces. Like if you want to do the general way of doing trace visualization, if you want to get deeper analytics, you can use Grafana and then write SQL queries to get all this. And in like we will be publishing all this SQL queries to the Timescale website, how to build and get this insight. So here you can see the SQL query. It's just like 8 lines of SQL query to get the error rate and try to understand what is being done here. So I'll just be a bit quick. So on the second panel here, we have operation with the highest rate in 24 hours. So it's the same. Like here you can see in the more visualized way that get ads is having the highest error rates, and it just continues. So there are few operations which do not have any error rates, and the slowest operations in last 24 hours. You can see which API, which operation is performing the slowest with P99 latencies, P999 latencies, and P95 latencies as well, and the duration. So front end cart checkout is taking 120 milliseconds. So if you have high uh, uh, rate of actions being performed, 120 milliseconds is a bit high. If you want like taking more than a second uh, to perform checkout is a bit anomaly, I would say. So you should definitely give a look and try to understand why is the P99 latency is like 6.96 seconds. So 99% of your requests during checkout are taking 6.96 seconds, and the duration median is 120 milliseconds. So like 99% of your request taking 7 seconds is definitely not okay. So just gives you an insight of how this is overall performing. And the slowest operation in 24 hours, here you can see that it's the health check and the checkout service. So these are some service performance analytics which are completely powered using the SQL queries. And we have something called tracing analytics. So let's see what are the analytics you can get from the tracing. So here you can see service dependencies. So we have the client services front end, which is calling the ad service with an API get ads, and number of requests it made is 2740 requests, and total execution time is 2.57 seconds. So you cannot get this kind of insights by just looking at a trace. So here you can understand the aggregated requests and how is the client and server performing on a specific operation. So here you can see that get supported currencies is performing 3953 number of requests. Maybe you can add a caching layer to reduce this number of requests to like by 3x or 5x just by caching the supported currencies. So yeah, and product catalog is taking closely 20,906 number of requests, so which is not okay. So you can definitely look at it. And here this is the heat map of trace duration. Like at 6 p.m. today you can see that a specific trace is taking 4.10 seconds of time. So it just gives you the distribution of traces on the based on the time consumed. And here you have the slowest traces. So here you can see the timestamp and the trace ID, the service name. So uh, an operation to cart is taking duration millisecond 2.37 seconds with resource tags as this. So here you can see this is the slowest trace, but you just know, okay, a specific trace ID is performing slow. But how do you catch hold of that trace? So here with SQL queries, we have added a hyperlink for that specific trace ID with an hyperlink. Once you click on that trace ID, it just jumps to a new tab of Grafana visualization to that particular trace. So here you can see, okay, this specific trace ID is consuming almost 2 seconds in get cart. So all the time is consumed here, and you can check and all the other actions in this trace are consuming like less than 2 milliseconds of that sort. So just you're directly jumping from the deep analytics powered by SQL to the trace which is causing the actual latency issue. So how, like, I do not know how what words to put together to give this kind of deep analytics to the observability land by using the SQL as the query language, and which is completely open source. And you should, like, just after this call you should be able to get all this insights from your clusters and applications right away. So you don't need to wait or you need anything else for this. So one last dashboard I just wanted to show is that, okay, do I have any dashboards left? Just look into the home or manage. So we do have some other dashboards. These are the Kubernetes mixins to understand how is your Kubernetes performing. So all these dashboards are by default out of the box shipped with the TOBS, the full observability stack for Kubernetes, which I was talking prior. So this is the complete dashboards we have. And let me jump into this microservices demo. Service performance trace analytics. Yeah, like that's all the dashboards I wanted to cover. So yeah, like you should definitely check out all these dashboards and get that instant value from your trace data and the aggregated views on how your services are performing. So that's all I have on the demo side of things. So if you want to just test all this tracing and the value we are talking about in this demo by deploying, these are the demo microservices I have deployed to capture all the traces you're seeing in the dashboards. So it's the original project is the Google Cloud Platform microservices demo. So there's a honeycomb fork with open telemetry instrumentation. So I have used this fork to get all this open telemetry data from this demo applications to the open telemetry collector straight into Promscale and querying it with the SQL and deriving the great insights from all the trace data captured. And if you want to learn more about Promscale, TimescaleDB, and how we are doing it, so we do have some slides and resources, not from this talk, but from a PromCon talk, which has detailed information. And I'll also share this slide deck in the YouTube comments uh, once this YouTube video is published in the YouTube. Like it should be published right after this talk. So I'll just add it there, and also I'll also add it to the uh, Twitter thread. And if you want to check out the tops, the observability stack for Kates, do check out this link. And Promscale is at this GitHub repo. And we do have many blog posts on high availability, continuous aggregates, exemplar support. So I haven't listed the Promscale features and all the TimescaleDB features due to constraint in time. But if you want to do check out what are the features offered by Promscale and how we do it, so you should check out the Promscale blog post. So we very often publish blog posts around Promscale, and talk to Promscale team if you are really interested to getting started with Promscale, either with metrics, traces, or for the observability stack for your Kubernetes cluster in TimescaleDB community Slack with hash Promscale as the channel. So I'll be active there. You can personally reach out to me in CNCF Slack or the Timescale Slack or even in Twitter. So you should be fine to test and like to get started with all this technologies and the single database store for all your observability data.
Yeah, I
And
think
thank you. That's all I have today. So yeah.
yeah, Vinny, thank you so much. I mean, that was a full power packed, presentation and demo. I really liked many things actually, and I have kind of uh, a few plans as well that I'll reach out to you because I see a lot of interesting things during the presentation. I also have a couple of queries regarding the performance benchmarking with respect to Quest DB and InfluxDB that I might reach out to you because there is this billion series stuff which people try to benchmark the time series databases with whenever they come to mind, and the top three that comes to my mind is the time scale and influx and the Quest TV, which is kind of coming up the ladder in some way because of the way it is getting structured. But I think Timescale is having a great kind of it is completely open source, though like products like Influx, they do have an enterprise version with kind of features which are only enterprise, the high availability for example, and for the high availability of the open source one, you need to do some of the additional stuffs with relay and all that stuff. So I have some of the ideas as well that I definitely discuss with you. I'll reach out to you for the slides and for the deck as well. As I think as soon as the video ends, if you add the comment when the video is published, it goes away. I don't know why. So when the video replay is available, then we will put that in the description and in the comment so that people can watch that. And definitely a very good stream. I mean, definitely people will learn a lot about metrics traces, how they work, how timescale works, how the architecture is work within the Kubernetes, how the prompt scale is working, how the open telemetry collector is working, where it fits into your application in terms of observability. So I think all those stacks have been covered beautifully by you. So kudos to the what you have brought today. Really enjoyed the complete session, and I'm sure that people have enjoyed. I see like already people want more information, like tell about Promlins, how it is integrated and all that stuff. We'll definitely talk about it later on. But yeah, thank you so much, Vineet, for giving your time, and thank you so much, people, for joining in, tuning in, staying till the end, and learning a lot of new things. Actually, Vineet talked about many, many, many things. And still it's not complete set of features for time scale, I'm pretty sure. So we'll definitely do something so that we can cover time scale in a way that like from the installation and deploying the microservices that we need showed, and then how to get that data and then visualize that. So we'll think of a mini series on that, how to do that. I'll plan that later on offline with Vineet and see how we can come out with a plan this year or next year early. So thank you, Vineet, for this, and thanks to the community for joining. Anything else you would like to add?
Yeah, I just wanted to just say one line. So all this observability and everything has just pretty much started very recently at Timescale, and this is just a beginning. So you should be seeing much more from the Timescale on the observability side of things. So just check out the space.
Okay, cool. Thank you all for tuning in. See you in the next stream. Next stream is day after tomorrow, and it's pretty awesome on Risk 5 introduction by Daniel. So that would be pretty epic. I always wanted to learn, Risk 5, what it does, architecture, and all this fancy stuff.
And
Okay,
that's all. Thanks for having me, Sayam. So bye.
bye.